Okay, so Jack from Smoky Mountain Scientific. Today we're going to talk about the OpenSCAD program for generating 3D printable spectrometers. Okay, so over here we have a rendering, well, a view of the body of the spectrometer, right? So you go in and download the SCAD program for Weetrometer Teensy Body 1B.SCAD, and this is what you see, right? This button here regenerates the rendering. This button over here makes it a little more polished. This button downloads the Stl file, and that one apparently is supposed to do some 3D printing, but we don't have it set up for that. All right, so in the Weetrometer Teensy Body 1B SCAD folder, you'll see this, and this generates the figure. All right, there's a bunch of information in here. This generates the figure based on geometry, and I'm working to get it to where you just enter the distances and angles and it generates the 3D model for you, but we're not quite there yet. Okay, so what we've got. So one thing you can do is you can change the height of the walls. We're set up here for 20 millimeter reflecting mirrors, and so I have an interior height of 31 millimeters. Okay, if you have a 50 millimeter lens or something and you want to put that in, you can change that number, change it from 31 to 51, and then when you hit the redraw button, you'll see that the height of the spectrometer body has changed. All the other dimensions, like the screw pattern that holds in the slit, they're all the same. So you can use all the same optical pieces with a different wall height. So let's turn that one back to 31, and 31, and then we'll go in and regenerate that. So now we're back to where we were. There's going to be a lot of different things that you can change from this program. You'll see a lot of things like focus 1 over here. That's the focal length from it's the focal length of the mirror over here, and it's the length from the center of the mirror to the center of the slit. Okay, that's if you're going to use the equipment that we can sell, then you'll want to leave that one unchanged, right? There's also an angle that you probably don't want to change, this angle 012, and that is a reasonably decent number. In terms of the nomenclature, all these upper things, they should be A for angle. Angle 012 means the angle between optical element 0, which is the slit, optical element 1, which is the mirror over here, and optical element 2, which is the grating. All right, so I guess I should tell you about the numbering. All right, so the optical elements are all named based on the order in which the light comes through them or hits them. Optical element 0 is the slit. Optical element 1 is the mirror over here. Optical element 2 is the grating. After it hits that, it comes over to optical element 3, which is the focusing mirror, and then optical element 4 is the CCD. Okay? All right, so when we number things over here in the text, in the code, you'll see things like A012. That's angle between optical element 0, which is here, optical element 1, which is over here, and optical element 2, which is there. So 0, 1, 2. If you find another one, it'll say A12 grat n, and grat n is the normal coming off of the grating. Okay, so the angle from, let's see, A1, there's 1 to 2 there, and the normal off of that grating, right? All right, so I guess I should change that number, but I didn't. Anyway, if you want to change these values, then hopefully we'll be able to do that. And you can see over here, if we wanted to change the angle to the grating normal from 9, let's say we want to change that to 12. And keep an eye on what happens to the angle here and the angle over here. When we hit the button now to re-render it, we have little slight changes in the angle there, right? So that is a benefit, I see, of this program. You can make changes to the geometry based on what you see and what you want to do. And it's not a huge pain in the butt. All right, so there are a lot of things in here that say not yet used, like D23. That should be the distance between 0, 1, 2 here and 3 over here. And what we're working toward making this this model infinitely changeable. Well, not infinitely changeable, but changeable from the first few lines of code. One thing that we can do is make a new lid for this, right? That's one thing that will be important if you change the numbers over here. You're going to have to change the geometry of the lid as well. And what's going to happen, you change a number, you'll change the, like this wall will change in its angle, and the lid will have to change. So instead of having a separate program to generate the lid, we have a variable called lid. It's a Boolean, and up here you can see it says lid equals true. That's been commented out, and here it says lid equals false. If we uncomment lid is true and comment out lid is false, then we'll generate the lid when we hit this button. Boom. Okay, so there's the lid. It's been flipped over. It should fit on the body of the spectrometer as you've generated the design. There's something a little funny going on over there I need to check into. I'm not sure what's going on. Anyway, this is a work in progress. I've just gotten to the point where I want to put something online describing what we've done. All right, so let's go back to lid being false, and there's that. All right, let's look at other things that we've got in the OpenSCAD. Okay, so here this tab says Fiber Connect Direct. All right, let's take a look at that. So what that is, this is a flange that fits over the slit hole, and it provides a mounting for an SMA 905 fiber optic connector. Okay, so the fiber optic connector will require a lens. That lens drops down into this hole. It needs a spacer. This is the spacer over here. This goes right on top of this. Screws in using number 4 sheet metal screws. These holes here are used to mount the piece onto the spectrometer, and then there's a metal fitting that you can purchase, and we've purchased a bunch of them, and we'll hopefully have them available for retail. All right, so that is how you connect the spectrometer to a fiber optic instrument. Let's see what we have next here. Let's see, we have this. It says Teensy Electronics Box, and this is the electronics box that fits the spectrometer to put a Teensy-based electronics on this. Over here we have the mirror mount. Okay, this is mirror mount number 1. There are 2 mirrors, so you have to have 2 different mounts. This is for the collimating mirror, and it's a 20 millimeter diameter, 100 millimeter focal length spherical mirror. All right, let's see. Grating mounts. You have to have a grating, and this is the inner grating, and here is the outer grating mount, right? The inner grating mount and the outer grating mount. These are for 13 millimeter square ruled diffraction gratings that you can buy from any optic store. And what we do, the plan here is you drop the grating down in this one, you drop this one on top, you turn it over. These little areas here will hold it in place, and you screw this whole thing to the spectrometer body. All right, so you'll notice that we have an angle here, right? So you can change that angle over on the left in the code. It says roll equals -3, right? So we can set that to 0, and we'll have a flat level grating mount, and you can change that to whatever value you need to have. I think I should have them at 0 just to characterize. Anyway, that is useful when if you find that you're not able to access the part of the spectrum that you thought you were going to be able to access, and you don't want to 3D print an entirely new spectrometer body, right? So you can just change the angle that the grating is held at. Okay, and let's show you where that thing is. So the grating fits into this little green square over here. The inner body mount, it goes up against this wall. The grating goes between the inner and the outer body mount, grating mount, and then you screw it in from the back, and that holds everything still. By changing that angle inside there, you change the angle at which the light comes off and strikes the focusing mirror over here. All right, the last piece that I have up here right now is the focusing mirror mount. Let's see what that looks like. Okay, the focusing mirror is a 20 by 50 rectangular mirror, and it goes up underneath this thing. Those little wings there, they hold the mirror in place. We have 1, 2, 3 mounting holes. Let's go back over to here and see where those attach. Okay, those 3 mounting holes, they attach through these holes here, right? And what we do is we put a piece of foam, squishy foam, behind the mirror, and you put the mirror mount on the other side of the mirror, and you screw, using sheet metal screws, you draw the mirror with the mirror mount against the squishy foam. All right, so once you have your parts designed the way you want them, then OpenSCAD makes it very easy to generate an Stl file, which is what you'll need to have in order to 3D print. You just click that button. It'll give you a way to get in and generate an Stl file. Tell you where to put it. Okay. Once you have your Stl file, you go into Cura or whatever slicing program you want to use, and you generate the G code from the Stl code. After that, then you're kind of on your own as far as printing goes, and let's see what and it's at temperature, so now we can look at it, and you can see that I am on the first layer of a lid print here, and that pretty much illustrates everything I wanted to show you. So that's about it. All right, I hope that's been helpful.